So next in this session, we come to a very interesting and important topic of functions. Okay, so functions are the baseline. I mean, not basic as such. Function itself defines makes C program special. So what are functions? We know what we saw in our examples, or even if we see this example, what we wrote here, there is only main. Okay, and what we have seen is main is also a function. Correct? So can we function without the name main? Yes, that is possible. Okay, and um, what? Why do we need functions? Why can't we do everything in main? Okay, meaning first I'll explain the need of a function using the. I'll take an example here. Why we need a function, or where a function can be used to efficiently code this. So what we did here is in the main function itself, we first sorted and shifted. Okay, we are shifting here. Whereas if I want to use, say this is a code, sorting is started, and here sorting ended. Now I want to do some other activity. Then if I have 10 activities to perform in a main function, then if I go on writing everything what's needed to do perform each activity in the main function, then the main function is going to be a humongous code when you're actually doing the coding for the real-time applications. Okay, not real-time, not the embedded, but the practical applications. So for that reason, we make use of functions. Okay? So what can become function? Maybe let's take a simple example. I'll remove all of this. Okay? So now what we saw in the switch case is we had switch case and we were adding, subtracting, multiplying. Now we'll define our function, add. I'll explain you. Till now what we saw is inside main was empty. But now I am planning to use two variables. Don't get confused. I will explain to you what are these things. Why int is here. Okay? Like we know int is here, but we are always returning 0. So first time you will see we return something other than 0. I'll make one variable int c equal to a plus b. Return will c. Okay. This is the function. This is the add function. Instead of doing this one inside the main function, I create a new function. Now, what do I do with this function and main function? Can I get away with main? No, that is not possible. Main is always needed. So you can use other variable int z. Okay. Add 5, 20. I explain you each and every step in this. Things that this is just to demonstrate how the function is working. If you have the previous result, "25" is coming. See, what just happened here is I don't have any code in the main. Meaning I do have, but I don't have a lot of mathematics in the code. I only called add. What is this add? This is this. Okay. This is called calling a function. Yeah. This is called calling a function. What are these two? Why I'm using this? This and all will cover in the uh, next slides. But main intention of the previous example was to show what can become function. Okay? The functional syntax, what are arguments, what is return type, all of that we'll discuss that in a full length. Here, what we're reading is this will make the life of a developer easy. Yeah, if you split the functions into, if you split the code into small pieces into functions, then it will make a life of a developer very easy because he has to only worry about that function at that point of time. Then again, that function will anyway be called in main function, some or the other way. With this, what do we achieve by doing functionality, by splitting the big code into functions? First one is the reusability, meaning I have this add function here. Okay, this add function I can call it 10 times. Okay, I don't have to repeat this code. Just by calling add, I can achieve this whole functionality just by calling this. Okay, this is what I meant by reusability. Okay. And if you come to a real life software development, then a project, okay, say you are doing some project, you have some functionality to achieve the software. So engineering a software to achieve some degree of some functionality. In that case, you cannot have a lot of functions in one file. Okay, meaning main.c cannot have 100 functions. Correct? We just spoke about functions. It doesn't mean I can have all the functions in one file. What actually industry follows is the modular is, and the modularization is also present at the file level. Okay, so I can have add.c file, main.c file, and still I can use add function defined in add.c in main.c in main function. Okay, this will show an example. How do we achieve this framework of multiple files in one project? Okay, and that's what industry uses. So if you see any code in any industry, you don't see one .c file. Okay, there will be different folders, and each will have a .c file, but all are connected. All put together is called software. So, can we call only the function inside a main function? No. What is possible is in this example or in this slide, what I have captured is there is a main function, there is a function one. Okay, and this function one is here. What we have here is called definition of a function. Okay, meaning this whole thing is called defining a function. This is called calling a function. Okay, so you cannot call a function without defining. Now, if I just comment it out, you can clearly see there will be error. You see there will be error. Is brilliant. See, undefined reference to add. Okay, so it's trying to refer this, but it's not defined because I just commented it out. So the point what I'm trying to make is explain what is definition. This is called definition of a function. This is called declaration of a function or calling a function. Okay. Coming back to this slide, what we have is defined a function. Inside this function, you can call one more function. This is also possible. Connector nested function calling. Usual industry standards, not standards, usual industry trend or the convention is there will be multi-layer of calling. Okay, there will be one main function that will call 10 different functions. Okay, each function will again call 10 different functions. In a very complex softwares like OS and all, okay, if you see a OS, I mean a simple plain OS, not the Microsoft OS, but a simple plain OS which runs embedded controllers. It's like say it will be while one loop. Your while one loop is a simple OS. While one loop meaning I have a while one and I run infinite number of times. So let me show an example here. Just try to demonstrate here. While one. So what we saw in while looping condition is as long as this is true. What we are doing by writing one is we're making it always true. So it will simply be there. It's like OS. The moment it comes here, there is no exit. Okay. When it will exit only after resets. Function 1, function 2. These might be different cyclic function which we want to run. Correct. And then here we have void function 1, something. Similarly, void function 2. Inside this, okay, function 1, function 1, function 3. Okay, this is very much possible, and not only possible, this is the way to code. We should not write big gigantic codes in one function. Try to split the code into smaller units. I think that's the flexibility what C program gives. Next in this lecture, we'll see what are arguments to the functions. Okay, so we already saw that we have a main function and then there is a function which is defined, and that function, let's see in this example, I have written a function called func2 and then there is a int x and int y. Okay, so what does this mean? It means the function 2, wherever it is called, will accept only two integers, int x and int y. That's how it's designed. So that's what you are seeing here. In the function 1, we're calling function 2, int a and b are passed. So these two a and b corresponds to this x and y. Okay. Let's see in this example here. Let me drag it to the screen. Yeah. So in this example, we can see again the same one, addition. It accepts two variables. Okay. So, and here we have a prototype. So what if I send only one variable? Okay. What if I send only one argument? You're going to get a compilation error directly. Too few arguments to function add. Okay. What if I send extra variable? Okay, you can see here I am sending character, the character, and it says too many arguments. Too many arguments to function add. So that's why it accepts two integers. Just now we saw an example where when I was passing character here, okay, and still this function was able to accept character even though we have mentioned the function to accept integers. Okay, in C program there is a concept called implicit conversion. So the lower data types like character will be converted to integer in these cases. Okay. So this is weakly typecasted language C program. So that's why these characters will be typecasted to integers. Okay. So that's why we are able to see a result even when we are passing character to a function which accepts integer. This is because of the implicit conversion. Okay. And there are compilers where these implicit conversions can be converted into errors. Okay. When you work in industry, or when you start working in industry, or if you are already working in industry, and when you do such things, you might see an error. Okay. Data type different in the functions called and passed, so something like that. That's because you can configure a lot of errors in the compiler when you are compiling. So, but whereas in the code blocks, these are implicit conversion. So a standard C rule is applicable here. But it's not recommended to use it like this. Always use it in this fashion. Okay. So can you pass? Can the float also be typecasted? Yes, it can be typecasted. That's what we saw at the beginning. Float CD. I'm passing float to a integer to a function which accepts integer. Okay. So the typecasting comes into picture, and here you have the answer. Let me show you the typecasting going wrong. Okay. Now we ideally we expect 65.5. Oh, but what we still get is 65. Because first of all, this itself is typecasted to 40. Yeah. So when not only the answer, we can still print here. Okay, let me print A here and show you what is this. See, first argument 40. When this 40 is passed to this function, 40.2 typecasted because it's an integer. That's why we have 40 here. Yeah. So this is about implicit conversion, where implicit conversion is working even when the function accepts integer. We can pass the arguments which can be converted to integers. Okay? But this is not a recommended one. I am explaining this because if this works in your practice and if it doesn't work in the industry tools, where you can configure different sorts of errors for a compiler. Okay, so you can also try configuring the warnings and errors here. Okay, so this is the option. You can explore this, but yeah, as of now, we can focus currently on the existing C program. So next year, we'll see what are these return types and what is the significance of return types. And let's understand. So now what we're seeing here is there is a function add, and when I'm calling the function add, I'm using this statement. So what does this mean? In this one, in the main function, what will be the value of z? Okay. What printing it here? This z here will be captured, will have a value of this return. Okay. So just to understand it fully, I will just make return 12. Okay. I'm simply returning some random integer. Okay. I'm not returning C, I'm returning 12. Let's see this return 12, which is integer here, will be coming here. So if you see, there is only one printf in this function. for the sake of understanding, let me comment this out. Now we can see there is only 112. Yeah, that's because z equal to add function. So it will come here. It will do all of this and return 12. And that 12 will be captured in z. Okay. Now, can we have a function without return? Yes, we can have a function without return. Meaning if I comment it now here, it's not a reliable function, okay, because I have an int here. As long as you're not using a return value from this is fine. But here we are using return value, correct? So this is not a reliable function. It will compile correctly, but the answers might not always be reliable. Okay, let me show you a demonstration. Okay, so here what we are seeing is 65 issues. What we are seeing is C is correctly returned back. Okay, let me make it int and we remove this decimals and compile this again. So what we are seeing is 65 is correctly returned, yeah, without a return statement. I have not used return C, but since there is an int here, it has returned last executed statement, but it's not reliable. We're not sure what it has returned. Accidentally it has written 65 here. Let's see. Let me enhance it. Apart from addition, I also want to do subtraction. Now what return? Let's see. There is a function add. It's an erroneous result, right? It's returning D. There is a C and there is a D. Both have some valid results, but it's returning D, which is at the end. So this is what I meant. It's not a reliable function. Where it's supposed to return something, it's not returning. In this case, though I have done this one, I'm ignoring what is there. I'm just returning C. Let's see if this works. Sure. This is returning 65. Yeah. This is the importance of return statement. Start. Next in this session, we'll see, can the function be without any return? Okay, meaning I don't want to write anything here. I don't want to return anything like this. Okay, void. And since there is no return, just leave it as it is. Okay. So in this case, so then you don't have to do anything. Just do this. So here, what's going to happen is, okay, still define one integer z, yeah. But if you look at a function, let's do a static analysis of a function. It will start from main 40, 25, and then there is an integer z, which is not at all used apart from printing. Okay, so we'll call the function add. We pass 40 and 25. It will come here 40, 25, add 40, 25, 40, 25, and store it in C, and D 40 minus 25. Okay, and return nothing. Go back to this function, print Z. So it will just print some garbage value of Z. Let's initialize this Z with some value. So it will just print Z equal to 77, correct? So, and I cannot write like this also, Z equal to, because it's not returning anything. Yeah. So it will just print Z as 77. So I think this is the error we have here. Yeah. So the prototype was not updated. That's updated now. So what we're printing is just 77, plain 77, and it's like this function good for nothing here, right? Not doing anything. So in these cases where you still want to add something, but you don't want to uh, return a value from this function. Okay. Let's add two numbers and need not returns anything. So in that case, what I'll do, I'll just take this function out, this variables out, or I'll define a variable z. Let's make it z. Yeah. Z equal to a plus b. And we have a z here. I'll make it a global variable. Yeah. So this is the global variable. And I come here, I do cd and add c and b. It will go here, z, okay, which is global here. So this global variable can be accessed here as well as here. So add it to run it. Sheet 65. Okay. So this is the advantage of using a global variable. You can use it across functions. Okay. We'll go through local and global variables later on, but this is a way how you can use something or how you can not have a return value to a function. Okay. When you don't have a return value, it's void. So when I have void here, that's why I don't use anything. I don't use z equal to y equal to add because it's not returning anything.